Good morning. I'm Manisha G from RMD Engineering College, Department of CSE. Now we are going to see about multiplexing. Multiplexing in 4 dimension, space, SI, T, time T, frequency F, code C. Multiple use of shared medium, important God space needed. Space multiplex, space is represented via circles indicating the interference range as introduction in figure. The channels K1 to K3 can be mapped onto the three spaces S1 to S3, which clearly separate the channels and prevent the interference range from overlapping. The space between the interference range is sometimes called God space. For the remaining channel K4 to K6, three additional spaces would be needed. The frequency multiplex, separation of whole spectrum into smaller frequency band. A channel gets certain band of spectrum for the whole time. Advantages: no dynamic coordination necessary, works also for analog signals. Disadvantage: waste of bandwidth if the traffic is distributed unevenly, inflexible. A channel gets the whole spectrum for a certain amount of time. Advantages: only one carrier in the medium at any time. Throughput high even for many users. Disadvantage: precise synchronization necessary. Time and frequency multiplex, combination of both methods. A channel gets a certain frequency band for a certain amount of time. Example GSM. Advantages: better protection against tapping, protection against frequency selective interference, higher data rates compared to code multiplex, but precise coordination required. Code multiplex, each channel has a unique code. All channels use the same spectrum at the same time. Advantages: bandwidth efficient, no coordination and synchronization necessary, good protection against interference and tapping. Disadvantage: lower user data rates, more complex signal regeneration, implemented using spectrum technology. Spectrum technology, problem of radio transmission, frequency dependent fading can wipe out narrowband signal for duration of the interference. Solution: spread the narrowband signal into a broadband signal using a special code, protect against narrowband interference. Side effects: coexistence of several signals without dynamic coordination, tap proof. Alternative: direct sequence frequency hopping. Effects of spreading and interference, spreading and frequency, selective fading. DSSS, direct sequence spread spectrum, XO of the signal with pseudo-random number chipping sequence. Many chips per bit result in higher bandwidth of the signal. Advantages: reduces frequency selective fading in cellular networks. Base station can use the same frequency range. Several base station can detect and recover the signal. Soft handover. Disadvantage: precise power control necessary. FHSS, frequency hopping spread spectrum, discrete changes of carrier frequency, sequence of frequency changes determined via pseudo-random number sequence. Two versions: fast hopping, slow hopping, several frequency per user bit, several user bits per frequency. Advantages: frequency selective fading and interference limited to short period. Simple implementation, uses only small portion of spectrum at any time. Disadvantages: not as robust as DSSS, simpler to detect. MAC protocol. Can we apply media access method from fixed network? Example CSMA CD. Carrier sends multiple access with collision detection. Sends medium when is free. Listen to medium if collision occurs. Problem in wireless network. Signal strength decreases with distance. Sender applies CS and CD, but collision happen at receiver. Sender may not hear collision, that is CD does not work. Hidden terminal, CS might not work. Hidden and exposed terminal. Hidden terminal, A sends to B, C cannot hear. C wants to send B, C senses a free medium, CS fails. Collision at B, A cannot receive the collision, CD fails. C is hidden from A. Exposed terminal, B sends to A, C wants to send to another terminal, C has to wait, CS signals a medium in use, but A is outside radio range of C, waiting is not necessary, C is exposed to B. Near and far terminals, terminals A and B send, C receives. Signal strength decreases proportional to the square of the distance. B signal drowns out A signal. C cannot receive A. If C was an arbiter, B would drown out A. Also, severe problem for CDMA network, precise power control needed. Access method: SDMA, FDMA, TDMA. SDMA, space division multiple access, segment space into sectors, use direct antennas. Cell structure, FDMA, frequency division multiple access, assign a frequency to a transmission channel, permanent, slow hopping, fast hopping. TDMA, assign the fixed sending frequency to a transmission channel between a sender and receiver for a certain amount of time. Aloha, slotted aloha mechanism, random distributed time multiplex, sorted aloha, use client sending must start at slot boundaries. Demand assigned multiple access. Channel efficiency only 18% for aloha, 36% of slotted aloha. Reservation can increase efficiency to 80%. A sender reserves a future in time slot. Sending within the reserved time slot is possible without collision. Reservation also causes higher delays. Typical schema for satellite links. Example for reservation algorithms. Explicit reservation according to robots. Implicit reservation, reservation TDMA. Access method DAMA, explicit reservation. Explicit reservation, reservation aloha, two modes. Aloha mode for reservation, competition for small reservation slot, collision possible. Reserved mode for data transmission is reserved slots. Important for all stations to keep the reservation list consistent. Thus, all stations have to synchronize periodically. Access method DAMA, PRMA, implicit reservation, PRMA, packet reservation, MA. A certain number of slots for a frame, frames are repeated. Station compete for empty slots using slotted aloha. One station reserves a slot successfully. Slot is assigned to the station in all following frames as long as the station has data to send. Competition for a slot starts again. One slot was empty in the last frame. Access method DAMA, reservation TDMA. Reservation TDMA, every frame consists of N mini slots and X data slots. Every station has its own mini slot and can reserve up to K data slots using this mini slot. Other station can send data in unused data slots according to round robin scheme. Multiple access with collision avoidance using short signaling packets for collision avoidance. Request to send, clear to send. A sender uses RTS packet to request write to sender before it sends a data packet. The receiver grants the right to send as soon as it is ready to receive. Signaling packet contains sender address, receiver address, packet size. MAC avoids a problem of hidden terminal. A and C wants to send to B. A sends RTS first. C waits after receiving CTS from B. MAC avoids a problem of exposed terminal. B wants to send to A. C to another terminal. Now C does not have to wait for or it cannot receive CTS from A. Polling mechanism. If base station can poll other terminals according to a certain scheme known for fixed networks can be used. Example, randomly addressed polling. Base station signals readiness to all mobile terminals. Terminals ready to send transmit random number without collision using CDMA or FDMA. The base station choose one address for polling from list of all random numbers. The base station acknowledges correct packets and continues polling the next terminal. This cycle starts again after polling all terminals of the list. Inhibit sends multiple access. Current state of the medium is signaled via busy tone. The base station signals on the downlink if the medium is free or not. Terminals must not send if the medium is busy. Terminals can access the medium as soon as the busy tone stops. The base station signals collision and successful transmission via the busy tone and acknowledgements respectively. Mechanism used, example for CPPD. Access method CDMA, collision code division multiple access. All terminals send one same frequency at the same time using all the bandwidth of transmission channel. Each sender has a unique random number. Sender exhausts the signal with this random number. The receiver can tune into signal if it is known the pseudo random number. Disadvantage, higher complexity of a receiver. All signals should have the same strength at receiver. Advantages, all terminals can use the same frequency, no planning needed, huge code space. Compared to frequency space, interference is not coded. Forward error correction and encryption can be easily integrated. Thank you.